Hello everyone, so now we are starting the next chapter, carboxylic acids and their derivatives, questions from MSc Elementary, and we'll be starting from question number 1. So question number 1 is, what is the acid anhydride that is hydrolyzed to form so and so compound? So basically benzoic acid and ethanoic acid is what they are expecting. So if we have to get the anhydride, basically the anhydride is a dehydrated version of your acids. So what we have to do is simply dehydrate them and then you will get the respective product. So this is my benzoic acid and this is my ethanoic acid. We have to do the dehydration of it. So you take H from one place and OH from the another and just combine them together. Just loss of water and we are done. We'll do the loss of water and we will get the respective anhydride. This is our option number B. Now come to question number 2. In question number 2, what is the product of the following reaction? So in the following reaction, we have to find out the product. Now understand what is the compound, what is the reaction. This is the compound given and we have to do the hydrolysis in the acidic medium. Okay, hydrolysis in the acidic medium is required. So we are doing the hydrolysis of an ester and hydrolysis of an ether. I think heat is not given. I have written heat by mistake. Okay, so when we are doing hydrolysis of an ester is C double bond O group. When we do the hydrolysis of it, the bond cleaves like this and water gets added like OH and H. There is a full-fledged mechanism for it which we have done in the class. So ester gets hydrolyzed to form the respective carboxylic acid and the alcohol in the acidic medium. Okay, so we are doing these questions by quick tricks. Ester hydrolysis always give you the respective carboxylic acid and alcohol, and ether also. If let's suppose I have an ether R1 and R2 and I have acid hydrolysis I have to do, so it will become this, and then H2 as a nucleophile will attack, this will cleave the bond and this will attack over here and it will form R1OH plus R2OH2 plus, which will eventually become R2OH. So 2 alcohol formation takes place. So we are going to do the hydrolysis. So basically these bonds are gonna cleave and here this bond is gonna cleave. I'll just change the color to make sure that you understand what I'm saying. So here it will be H and OH which will come, and here also H and OH. So hydrolysis if you'll do, this is how the water will be getting added. So for esters as well as cyclic ethers, for both acid hydrolysis takes place and we get the respective alcohols when you have ether, and we get carboxylic acid, and this is your carboxylic acid and this is your alcohol. Carboxylic acid and alcohol forms after hydrolysis of ester. I hope you have understood. I think I have messed it up a little bit. Just repeating it once again. Esters on hydrolysis give respective carboxylic acid and alcohol, and ethers on hydrolysis give the respective alcohols, 2 alcohols. So this is how the molecule will look like. It will cleave into these 2 compounds and that's how it will look like. So this is your option number C. Now in question number 3, we have been asked which of the following compounds is hydrolyzed more rapidly in aqueous NaOH. So see, when you have to do the hydrolysis, we have to do the reaction which is pretty much like a S into TH type reaction where your OH minus will attack. It is happening in the aqueous NaOH. So OH minus will attack first as a nucleophile on the carbonyl carbon. Oxygen will get the electron density forming RCO minus OH, and then there will be a leaving group. So better the leaving group is, faster the reaction would be. Also stronger the delta positive on this carbon, faster will be the reaction because nucleophilic attack will be faster. Nucleophilic attack is an RDS. So 2 factors are the ones which decide. One is delta positive on C double bond O, and secondly good leaving group. So looking at these factors, we will see we have RCONH2, RC double bond ONH2. In this you have this as a plus M group, minus I group, plus M greater than minus I. So it is donating, delta plus density is decreasing. You have ester group. Ester group also have same thing. It is plus M greater than minus I. So obviously delta positive density is decreasing. Then comes your RCOCl. RCOCl mein minus I is greater than plus M. So definitely delta positive is increasing. Also the chlorine is a very good leaving group. So that is one of the reason why this is the best one which will get hydrolyzed faster. Apart from that, there is an anhydride where the leaving group is good, but again it is a plus M greater than minus I. So donating group, so delta positive is lesser over here. Okay, this is plus M. So delta positive is lesser. And same case goes to carboxylic acid. In case of carboxylic acids, the reaction may not happen in the same way. SN2TS, the reaction will go in an acid-base type of reaction. So we can't do the reaction on E. E will be in fact a kind of a reversible type of reaction. Here RCOOH will react with NaOH to form RCOONA. So it's not a hydrolysis reaction. So the only option which is correct is option number C, where you have a good leaving group. Also you have a strong delta positive on the C double bond O. So now come to question number 4. In question number 4, again it has been asked which of the following compounds is hydrolyzed most slowly in aqueous NaOH. Again they are talking about the hydrolysis in basic medium. We have to check where the delta positive is least, and also where is the worst leaving group present. So when we'll go through that and when we'll see, so if we can see RC double bond ONH2 in this case, so nitrogen is the worst leaving group among all, and hence delta positive, so we can clearly check most of them are showing plus M only, right? Oh, except RCOCl. So majorly we will have to see which one is the worst leaving group. So NH2 is the worst leaving group among all, and hence the answer will be B. So two factors are there, delta plus and the leaving group ability. I think here the main factor which will decide the slow hydrolysis is nothing else but the leaving group ability. Now come to question number 5. In question number 5, they're asking esters and amides are more easily made up by nucleophilic acid substitution reaction on. So esters and amides both can be formed by nucleophilic reaction on which compound? Though we can do it in any of the RCOG compound, but you should have, as I told you, good delta plus and better leaving group. So among all the compounds given, we have alcohols, acid anhydride. Alcohol में तो बन ही नहीं सकता है. Acid anhydrides, carboxylates, carboxylic acids. Again, alcohols and carboxylic acids both are acidic in nature. तो वहाँ पे reaction may go in a different manner. Now come to acid anhydrides and carboxylates. There the leaving groups are bad as compared to acid chloride. So here delta plus is also higher because of minus I, and also chlorine is a good leaving group. That is the reason why this will be preferred compound to form esters and amides. Now let's talk about the question number 7. In question number 7, we have been asked, now hydrolysis of ester in base is called nothing else but saponification. Saponification is specifically the basic hydrolysis of an ester. So if you do OH minus NH2O, your ester gets converted into RCOOH plus R-OH. This process is called as saponification. Now come to question number 8. Which of the following conditions will drive the equilibrium of Fischer esterification towards the ester formation? See, whenever we are doing the esterification reaction, this is generally a reversible reaction. And in this reversible reaction, if we do not remove water content, then the reaction may go reverse. In acidified, hydrolysis may take place. So ester is forming and water is getting released and the medium is acidic. If we do not remove this water, then in that case, this will again attack here in the acidic medium and will do acid hydrolysis and will form RCOOH and ROH. So removal of water is must if we want to move the reaction in the forward direction. If we do not remove water in acidic or basic medium, whatever it is, then the reaction will go in the backward direction. In basic hydrolysis can happen, acidic hydrolysis can happen, though in esterification the condition is acidic. Hence we are majorly talking about the acidic hydrolysis over here. So water content removal is a must. Now let's talk about question number 9. What is the product of the following reaction? In this reaction, ester is given and or water with 18, oxygen 18 is given. Now see the reaction. We have H2O with H plus will attack on the oxygen, will make it protonated alcohol. Oxygen will try to withdraw the electron density, increasing the delta positive charge on this carbon, and the oxygen's lone pair from here will attack here, and all the molecule will look like this. So basically this OH will become single bond OH, OH2 plus will form with O18 and there is an oxygen over here. Now this OH2 18 will try to give away one H plus, so minus H plus, and we will get OH plus. Now this H plus after that will attack on this ether oxygen because this is more electron rich. So when it will attack, the molecule will look like this. Now to get rid of this positive charge, the oxygen will try to cleave the bond, will cleave the bond from here, and this is how the chain will become open. So with this side we'll get carboxylic acid and this side will get, other side will get alcohol. Now how did we got this double bond O? Let's understand. So when the bond cleaving would have happened, at that time this carbon would have acquired, let me just write it again. So this is something how it will look like after bond cleaving. Okay, so this oxygen will also give the lone pair, and this H will be out, and eventually forming the double bond. This is how it will look like. This is the carboxylic acid which we are getting, which is your option number D. Question number 10. Which of the following is most reactive towards the Grignard reagent? The one which will have the most delta positive, because it's a nucleophilic addition reaction. Definitely the reaction will go in that direction. So we will see all the compounds. If we see aldehyde, CH3CHO, there is a donating group, hence delta positive is decreasing. We talk about CH3C double bond OCl, we have a minus I effect over here, which is greater than plus M, and hence this is delta positive is increasing. Okay, then comes your CH3C double bond OCH3, definitely two donating groups, delta positive will strongly decrease. So out of these three, at least this is the answer so far. Let's check the fourth one also. Fourth one is CH3C double bond OOET. This is also donating through plus M. Hence none of this will be answer but B. B will have the maximum delta positive charge on its carbonyl carbon, and hence the reaction will be fastest in case of 10th. It will be fastest in case of B.